Hi everyone, this is Sharan here. Welcome to my channel. In the yesterday's video, we saw the basic support SVM algorithm. We saw what are all the various scenarios where SVM algorithm can work best. So we saw how it can be used for both linear as well as non-linear problem. We saw the various T terms in SVM algorithm, such as what is a support vector, what is a margin, what is maximized margin, what is an hyperplane, what is the mathematical equation behind the hyperplane, right? How do we come up with the hyperplane? And what are all the two different problem sets when we are trying to solve an SVM algorithm, like what is linearly separable and linearly non-separable? What are all the options that we have in order to solve a problem which is linear but non-separable? So if you have any doubts in any of these concepts, please go back to my previous video, which I will link it in the top, as well as will provide you the link in the description, so you can go through the video and understand the basic concepts behind an SVM algorithm. So once you are aware of the basic concepts behind the SVM algorithm, so let's move on to the simple implementation here to learn how to implement an SVM algorithm using Python. So what we are going to do is we are going to start with a simple implementation where we are going to input a small data and then see how can we use SVM in order to predict the classification. And then we are going to take up the heart disease data set, which we have seen previously in the classification tutorial. So what we are going to do is we are going to see how to make use of SVM algorithm in the and make the prediction for the heart disease data set. We will also be using a concept called as grid search, where we pass various hyperparameters, we pass various options, and using the grid search, we let the algorithm try out different combinations and then see or use the best one that comes up with the best prediction. So we are going to see how to make use of grid search and implement the SVM algorithm. So these are all the various concepts that we are going to see today. So let's start with the first one. So as you see on my screen, there is a simple example which is saved as a separate Python notebook file. There is the heart disease data set for which we are going to solve using the SVM algorithm, and then there is the heart disease data set. So this is a data set that we have previously used, so you must be familiar with it. So the first one is a simple example. So here in this case, so first before starting off, let me clear the outputs. So here in this case, we are going to make use of a NumPy, and we are going to make use of an package in order to implement the SVM algorithm. So these two are the packages that would be required. So we are going to import both of them. So let me import both of them here. And second one, what we are trying to do is we are trying to come up with two inputs. So one is the various data points. We define various data points using X, and what we do is we use Y in order to classify them into different groups. So as you see here, the X holds the various data points. So here we have two values, like the X-axis as well as the Y-axis. So we have four data points in total, and the Y attribute holds the two different classes. So for each of those four data points that we have, what is the class that it belongs to? So that's what is provided here in this case. So what I'm going to do is I'm just going to read it so that the values are available in X as well as Y variable. So then what I'm going to do is I'm going to use the SVM algorithm. So we are going to use a simple linear algorithm because this is a simple example which is linearly separable. So I'm going to use SVC, which calls the SVM algorithm, and I'm going to use the kernel as linear because in this case it is enough for us to use a simple linear SVM algorithm to do the classification. And then we use .fit in order to train the model based on the dataset that we have. So what is the dataset? The X and Y. So let me execute this particular script here. So now the model has been defined and it has been trained by the small input data that we have. The next one is making the prediction. So we use CLF, so which holds the actual model and which is being trained on the dataset that we have, and we use CLF.predict and we pass on the new data point. So 4,6 is a new data point. We pass on the new data point and then we want to see what is the class that it belongs to. So let me execute this and show you the prediction. So here the output is 2. So as you see here, these two data points like 1,3 and 2,4 belongs to the class 2, whereas -3, -5 and -2, -2 belongs to the class 1. So here when I pass on 4, 6 as an input, the algorithm is able to predict that it belongs to the class 2. So let me change this to negative. So let me say this is minus 4 comma minus 6. So now let's see what happens. So now as you see, the model predicts that it belongs to the class 1. So here in this simple example, if you try to imagine the various data points that I have, so what happens is it is either x and y both are negative. So if you consider an x-axis as y-axis, there is various data points here on the left bottom, and then there is various data points on the right top, which is like both x and y are positive, and here on the left hand side bottom, the x and y both are negative. So whenever we pass on x and y as negative, it is able to classify that as the group 1. Whenever the x-axis and y-axis is positive, it is able to classify them as group 2. So what happens is there will be an hyperplane somewhere in between, so which would be in this particular angle because we have 2 data points here. So this is a simple example in order to build an SVM algorithm. So then what we are going to do is we are going to move on to the next data set. So this is the heart disease data set. So what we are going to do is first let me clear the output. So these are all the various packages that we will be using for solving this particular use case here. So let me import all those. So it is nothing but pandas, numpy, seaborn for visualization, and SVM algorithm. And in order to measure the accuracy of the model, the confusion matrix, as well as the accuracy score, and in order to split the training as well as test data set, we use a package for that as well. So these are all the packages that will be used for today's session. So the next one is we are going to read the data set. So let me execute this and then read the data set. So this is how the data set would look like. It has various attributes such as gender, age, education, whether smoker, and a number of cigarettes per day, BP, medicines, and various other parameters. So these are all the various parameters that are available for us. So next what we are going to do is we are going to remove all the NAs. So having a large number of NAs could be an issue for the algorithm. So as I said, SVM is not suitable when we have a lot of noise. So in this case, what we are trying to do is we are not going to solve the NA problems. We are not going to see how to replace the NAs with the most suitable value. But for the simplicity of the example, what we are going to do is we are just going to drop all the NAs and assume that there is no NAs that is present in the data set. So let me execute this and drop all the NAs that is present in the data set. The next one is we are going to separate the dependent variable as well as the independent variable. So the variable that we are going to make the prediction and the other variables that will be used as an input. So let's separate these two variables here. So we are going to pass it in x as well as y. So let me execute it. And then what we are going to do is we are going to separate them into a training dataset and test dataset. So here in this case, we use 0.2 as the test size, which means that 20% of the records would be considered or would be set aside for the test, and remaining 80% of the data will be used for the training purpose. So let me execute this and let's divide the data into the test as well as training data set. So the next one is we are going to use the SVM algorithm. So here in this case, the data set has a number of dimensions, and hence most likely it is linearly non-separable. And what we are going to do is we are going to use the gamma functionality, which defines the importance that can be given to the new feature. So we use gamma as auto to leave it to the algorithm to choose the best option that can come up with the best prediction. So let's define the SVM algorithm here. And let's use the dot fit functionality in order to train the model based on the data set that we have, the training data set that we have. So this would do the training. And finally, we use a clf.predict in order to make the prediction. So this has made the prediction. And finally, we use the confusion matrix as well as the model accuracy to see how good the model is performing. So as you see here, the accuracy for this particular use case is about 84.28%. So which is pretty okay. So what we can do is we can tweak the number of parameters that we are passing here and then see how well we can improve the algorithm. So the next one is the concept called as grid search. So the grid search is, let's say when we have a number of parameters that can control the accuracy of the model. So in this case, what we have is we have something called as a gamma. We have something called as an C, which is the soft margin, which defines how many cases we can misclassify without causing any issues to the model as such. And the drama defines like what should be the importance that can be given to the new features that is getting generated. And also it has various options for kernel. So these are all various parameters that can be used and that controls the accuracy of the output that we are able to produce. So what we use is we come up with various options. For example, here in this case C, we come up with 5 different options for C. Similarly for gamma as well, we come up with 4 different options. And for param grid, what we are doing is we are saying like these 2 are the options for the algorithm to play around. So then what happens is the search grid would try various combination, like it will try 0.001 with gamma of 0.001, and also with the second one, third one, like it tries various combinations, and it will try to identify the best combination that helps us to come up with the best prediction. And finally, what we can do is we can identify the best parameters. So now let me define the grid search here, and then using this one, so we actually use the fit in order to train the model, and we use the best parameters to identify what are all the best parameters that works good. So by executing this one, what will happen is, so this takes a bit of time, but what it will do is it will come up with the option for both C as well as gamma that works well, like out of the available options that we have. Within these options, it will try to choose the best combination that works well for the prediction. And once we got the best option, so then what we can do is we can use the best parameters, and we can use the predict function in order to make the prediction. And again, we can make use of the confusion matrix to see how good the algorithm is performing. So maybe this takes a bit of time. So what you can do is this code will be uploaded in my Git repository. You can try to copy this code and then try it out. So this accuracy that will be produced here will not be much different from what we have here. So it will be most likely like almost the same. But maybe the other options that would help you in improving the accuracy is try out various different options. Like try to increase the number of options for both C as well as gamma, and maybe try to introduce kernel as well within the search grid to see so here we are using RBF. So there is something called as a poly, so which will try to come up with an polynomial polynomial transformation for coming up with a new feature. So that might help in coming up with a better prediction as well. So you can use kernel in the grid search as well. And finally, in order to learn more about the SVM algorithm, so here is a simple example which would take you to the Cadel website. This has a script which uses various algorithms. So SVM algorithm is also solved using this particular script. So this is quite detailed. You can go through the script to understand how to solve the heart disease data set and come up with the best prediction. Along with these links, I will also try to provide you some of the references that you can make use to read and understand the SVM concept much better. So that is it for today. I hope you have learned something new. If you have learned something new, please subscribe to my channel as well as give a thumbs up. If you think this might be helpful for someone, any of your friend who is trying to learn data science, please share it with them as well. That is it for now, and bye until I see you in the next session.